Techlandia is recorded at the central office on the east side in Portland. Central Office is a one stop for all your office or meeting needs. Check them out at centraloffice.com. Welcome to Techlandia, a podcast about and for the technology industry, a place to learn, connect, and engage with leaders and thinkers involved in the technology industry. You can check us out at techoregon.org, Apple, Spotify, or wherever you listen. Thank you for listening and enjoy the show.
Welcome, everyone, to the latest episode of Techlandia, TAO's regular podcast series. I'm Skip Newberry, President and CEO of TAO. And with us, we have Tom Weller from Oregon State University. Tom, thanks for joining us.
Hi, Skip. Glad to be here. Thanks for the opportunity.
And Tom, I wanted to have you maybe take a few minutes to share a little bit of background with our listeners about your own professional journey. What can you take us from up to present day? How did you end up at Oregon State University and in your current role?
Sure. I completed my undergraduate degree in electrical engineering in the late 80s when there was significant boom happening in the aerospace industry. And like many of the people I went to school with in the Midwest, I found myself in California working for a large aerospace company, which got to know a lot about how industry works, but also that I was really interested in going back to graduate school, which I did, and spent a lot of time working in a clean room throughout my graduate research, which is definitely connected to the types of things I'm doing these days. And I entered academia at the University of South Florida in the mid 90s, and I also had an opportunity to get involved in some startup um, companies during that time as well, which is also, I think, very related to the type of work that I'm doing now at Oregon State, which I joined in 2018 as the school head in electrical engineering and computer science. And for the past 2 years, I've been part of some large initiatives that we've been working on in the economic development space connected to the semiconductor industry here in Oregon.
Excellent. And it's interesting to come across someone who's worked in academia, but also has had experience in the private sector, let alone also involved with startups. And I was wondering if you could share for our audience just a little bit about some more detail in terms of some of the work you were doing in the startup world.
Sure. Well, when I was at University of South Florida, we were contacted by Motorola, who was at the time designing and manufacturing products for the wireless industry all over the globe. And this was at a point where electronic design automation was becoming very prevalent in the wireless space. And they had designers in different design centers using completely different models for their components in their handsets and their pagers at the time that they were manufacturing. And so we got started on a project to standardize the way that um, uh, models for components and systems were developed and documented for electronic design automation. And Motorola adopted those models as kind of their worldwide library. And ultimately, that became an effort that was too large to continue in a university setting. So that became the basis for a company that we started called Monolithics. And so that company is still in operation today and providing measurement and modeling services to companies all across the world.
Nice. And in terms of your work at Oregon State University, I was wondering, so you've been involved and we've been involved with you in some different opportunities going after federal funding, focused on research and commercialization, workforce education, new company formation, and startup support. Um, I was wondering if you could take a minute to just describe some of the more current kind of active opportunities that you're involved with on behalf of Oregon State University.
Sure. So we have several smaller programs in the research and workforce development space. Um, One of them, Oregon State, is a member of the Northwest AI Hub, which is led by Stanford, and that's part of a DoD program called Microelectronic Commons. And that's a consortium of 6 universities that are collaborating to develop new circuit design courses in AI. We have some internship training programs. We have created a program called the CHIPS Lab, where we bring incoming engineering students in for a week in the clean room. Um, we also have a similar type of program funded by the Higher Education Coordinating Committee here in Oregon called Vets Up, where we're providing 8-week training opportunities to military veterans in collaboration with Analog Devices and their training facility in Beaverton. So we have a handful of programs like that that are really sort of OSU centric, but I think the ones that are even more exciting are these large collaborations and initiatives that are really encompassing not only research but also workforce development and then translation of research into commercialization. One of them is the Corvallis Microfluidics Tech Hub, which is a program managed by the Economic Development Administration. And I'll get back to that in a moment. But the second one is the Frontiers of Advanced Semiconductor Technology Regional Innovation Engine, and that is a program from the National Science Foundation. So Cormic, which is the Tech Hub program, and FAST, which is the NSF program, these are consortia that have 65 and nearly 100 member organizations, respectively. And they really are focused on um, establishing collaborations and partnerships between not only higher education, but also the private sector, regional and state government agencies, venture organizations, and economic development groups across the state. And these are, really, I think, novel programs, kind of following a pattern of what federal agencies have been trying to establish across the country. Um, so I could go into a lot more detail on either of those, but maybe I'll turn it back to you, Skip, to see if you have specific questions about either Cormic or FAST.
Yeah. So with Cormic, my understanding is, it leverages technology that was developed in Oregon quite a while ago and applies it in an interesting way to addressing an issue with yet another technology. And I'm wondering if you could describe a little bit around some of the research focus and sort of where things stand from a commercialization standpoint with some of the private sector partners.
Yes. Yeah, I think it's really a fascinating story of, as you said, this is a technology which is based on um, microfluidics, which was invented here in Corvallis by HP, and using thermally excited microfluidics for inkjet printing, which is the original main application for the technology. It has since been further developed over the last 30 plus years by HP and applied to things including printing of human cells in the biotech space. So very, very versatile technology, number one, and number two, it's a very multidisciplinary technology, and HP arguably has uh, one of the best groups, if not the best group, in the world in terms of understanding how to not only make the technology work, but make it work in a high volume manufacturing type of situation, which is really super critical when you're trying to commercialize a new technology, especially something like microfluidics, which um, oftentimes organizations try to develop their own solutions and frequently run into to technical roadblocks. Whereas HP has the know-how to help companies solve those problems. So the concept behind the Tech Hub was to really make that HP developed and refined and perfected high volume manufacturing capability available to other companies coming through and uh, working with the Tech Hub to transition essentially ideas that had already been demonstrated in a real world scenario, but hadn't yet been productized and cast into a form that could be made cost effectively in high volume. And so the promise there is, as I see it, and what I think is especially exciting is, whether it's graduate students or research faculty or small companies that are developing a new technology using microfluidics, the promise of the Tech Hub is that it essentially identifies the path that these researchers should be following to be successful and efficiently scale up their technology so that they can compete in the global um, marketplace.
It's really an exciting opportunity for Oregon, and then you also mentioned the FAST Semiconductor Initiative through NSF. So what's the current status of that in terms of potential funding from NSF, and what would you like to see more of in terms of industry participation going forward?
Right. So FAST, the concept there that we've essentially built our proposal on over the last year and a half is to leverage the strengths in the semiconductor industry here in Oregon with the uh, capabilities in artificial intelligence. And the thing that was especially exciting when we started going down this path is what we found is essentially every company, whether it's in the design or the manufacturing or the packaging of semiconductor devices, they're all turning towards AI to improve the way that they run their businesses and the performance of their devices and so forth. Um, but oftentimes they don't have enough talent themselves to develop the AI technology that they need. So this opportunity to be part of a consortium which is really focused on that integration of AI and semiconductor design and manufacturing was a very easy sell for every company that we talked to, and they were all very interested in being part of this consortium. So, um, and that really aligned quite well with the concept that the National Science Foundation was promoting, is that the research that's being conducted in these engines is use-inspired research, which essentially means that the National Science Foundation wants technologists from industry working directly with researchers in academia and in small companies to essentially identify the way forward to the types of solutions that that researchers should be working on, which significantly increases the likelihood of eventual commercialization. So we submitted what we feel is a very competitive proposal. As I mentioned, we had over 100 organizations that are part of the consortium. And at this point, we're hoping to hear very soon that we will have a virtual site visit by the National Science Foundation sometime towards the end of July. And if we're successful with that site visit, then there would be an on-site visit over a couple of days sometime in September. So that's the status of FAST, and I think what maybe the most important part of your question is what are you hoping to see from industry and other members of the organization? Well, first of all, we are moving ahead as though we're already a fully operational engine, even if we don't yet have funding. And so we're doing things in the innovation space, we're doing things in workforce development. We're trying to increase the number of collaborative research engagements that we have ongoing. But we really need to make a very strong showing to the site review committee that we have committed members of the consortium, and that's a pretty tricky thing to do when you have a bunch of organizations that really haven't worked together in the past.
Right.
But we've done our best to make it clear to everyone what the opportunity is, and like I said, we've gotten a very good response. But making sure the National Science Foundation knows that is critically important.
Well, that's definitely a great sort of call to action. If companies in the area that happen to be listening to this, are interested in the focus and aren't already signed up and involved, we definitely want them to be, especially ahead of these virtual or potentially in-person site visits coming up very soon. I think a lot of this work also underscores Oregon State's kind of strategic positioning nationally, right? Which we've got a huge portion of the nation's semiconductor workforce. 15% is in Oregon, and Oregon State is a really important piece of that ecosystem, both from a research standpoint, but also on the workforce and talent development side of things. And despite having a large concentration of workers here, the growth that's projected in semiconductors over the next 10 years still leaves us with a bit of a gap that's anticipated on an annual basis that's over a 1,000 or so positions. And I'm wondering, how is OSU working to address the talent gap, both through a combination of upskilling as well as responding to industry?
Yeah, and that is, as you pointed out, is a potentially a very significant shortfall. And some of the conversations we've had suggest that we might need to be producing 3 times more graduates with degrees in relevant fields in the next 5 to 10 years than we're doing today. So, um, uh, in
No easy
terms of
task.
work, well, yeah, it is. It's a pretty daunting task. So, today in Oregon State University, we have over 45 faculty members who are in this area of semiconductor science and also AI. And, both of these, of course, are critically important to the future workforce in the industry. We continue to be committed to bringing on new faculty hires in the semiconductor space, and we're currently graduating over 1,000 students every year that are in the semiconductor relevant fields. Um, However, despite the fact that we're educating a lot of graduates in these areas, they don't all go into the semiconductor industry, and so that's another challenge is really creating much greater awareness of the opportunities, whether you're an electrical engineer or a computer scientist or a mechanical engineer or industrial engineer, chemist, you name it. Uh, a lot of students just don't uh, understand the breadth of opportunity that there is in the semiconductor industry. So, awareness is one of the first things that we're trying to address. And one way that OSU, working with a number of our partners, is developing what we're calling the Oregon Semiconductor Central website. And we're actively building this website right now. We're working closely with a task force which has been formed by the Oregon Business Council on semiconductor talent development, essentially to bring together all in one space all the different types of career pathways that are available in semiconductors, and why the industry is so important to the state. And you can find that information. It's just hard to find all that information in one place. And we're in some ways following a pattern that the Higher Education Coordinating Committee has done in other industries, like construction and nursing and healthcare. Um, so, building awareness is the first thing that we're working on. The second thing we're working on is creating, and this is really in response to what industry has told us is important, is these transferable pathways and making it easier for people as they progress through training programs and perhaps 2-year degree programs and 4-year degree programs, just making it much easier for people to get on and off that pathway depending on their life circumstances. And it sounds like it would be straightforward, but there's actually a lot of challenges in doing that. In fact, we have a big meeting tomorrow at Chemeketa Community College, and the focus of that meeting is how do we start creating these, uh, streamlining the process of going from a 2-year degree to a 4-year degree without losing, a full year or more, just by making that switch. Um, so there's awareness, there's these pathways, and then other things that we're doing are creating these stackable credentials, as we call them, where we'll have a series of maybe 3 courses that would fall into a micro credential,
Mhm.
and that might be in something like, semiconductor processing or supply chain, something that someone might be interested in, and they get this micro credential, and then they may decide, well, let me get another micro credential, and eventually that becomes a certificate. And then if they add some additional courses on top of that, it can become a complete 4-year degree. And this is really a national trend that's being promoted very heavily, and it's all about flexibility and accessibility and affordability for people that are trying to go through these pathways. Um, so I think it's really a combination of all these things that we are pushing forward to try and achieve this, as we said, pretty daunting task of tripling the output from our educational and training programs.
Yeah, it's a pretty exciting, I think, moment, really, in terms of the state of technology and for Oregon State University's kind of position within that. One of the things that's really captured folks' attention, at least within our membership and network, has been the Collaborative Innovation Complex and the new supercomputer that was donated by Jensen Huang of NVIDIA. And I had a chance to chat with one of Jensen's co-founders, who was hosted at an event at OSU by the president of OSU recently. And when I asked him, what's the one thing in the way of advice you'd give to Oregon's leaders and how best to kind of leverage this asset, this computing infrastructure, he said, focus on workforce and education resources. that is going to be the thing that's going to enable the greatest number of folks to potentially realize their full potential in terms of entrepreneurship as well as employment opportunities. And so it's exciting to see Oregon State University playing an important role there. I'm wondering, as you look forward from the view of the College of Engineering, like what's the future state, and what are you hopeful for Oregon State University's role in that?
Yeah, I'm really glad you mentioned that uh, focus on workforce development from the Collaborative Innovation Complex, the long Collaborative Innovation Complex. And one thing that is, I think, changing in response to this need for workforce development, and it's not just in the semiconductor industry, of course. There are many other industries who are going to be faced with shortages of STEM workers. Um, and, many people would describe the relationship between industry and higher education, whether it's community colleges or universities, as somewhat transactional in nature, and that really needs to change. And I do feel that that is definitely starting to transform. And in some ways, maybe it's resembling some of the types of relationships that exist in Germany and other places in the world where they have a very tightly integrated industry and higher educational partnerships. And so, it super important step that Oregon State took in that direction recently was creating the Economic Development and Industry Relations Office, and that's really focused on having a highly coordinated front door to partner with industry, not just on research but also on workforce development. And then thinking about the Wong Collaborative Innovation Complex, sort of the whole essence of that is not just collaborating across different centers on campus, but it's also collaborating with people from outside the university. And I think there's some really great opportunities to develop some novel training programs. And if you were to ask what can industry change about the way that we educate our students, it's not going to be really having a significant impact on that broad-based education, which is very important for lifelong, success of our students. What industry can do best, I think, is help the university with experiential learning, which is most of the time when students get really excited about one particular field or another is when they get to do some hands-on things with modern tools and modern equipment and really understand what it's like to work in industry. And whether that's an internship or an apprenticeship or short-term training or shadowing engineers, I think we need to have this kind of interaction on a more consistent basis and really institutionalize that kind of relationship as opposed to a series of one-offs, which are much harder to maintain.
That's a really good point. And I think too, like as an association that works with a lot of tech company employers in the area, it's been exciting to be able to collaborate with Oregon State University in helping to provide greater access to educational benefits to area companies, and so it's really great. We've got a 15% tuition benefit scholarship, if you will, available online through OSU eCampus, which is kind of cool, and it just underscores kind of your point about meeting people where they are and having that be an important focus of where universities can address some of the workforce needs and upskilling and reskilling needs on the part of professionals. And with things like disruptive technology like AI in the mix, things are moving at a fast pace, and so are requirements when it comes to updating skill sets. And universities have a huge opportunity to play there. So it's exciting to see OSU's work and your role in that, Tom. And since your time arriving at the school in 2018 to today, you've left a huge mark on the program and a lot of the external relations and partnerships. So, yeah, we're really pleased that you were able to take some time out of your busy schedule and join us today. And before we wrap up, I just wanted to see if there were some kind of final remarks that you might want to leave our audience with.
Well, I would go back to this idea of first of all making sure uh, that there's a much greater awareness of how important the semiconductor industry is to Oregon, and certainly there are other places in the country where significant investments are being made in this industry. But right now, as you pointed out, there, we have the third highest number of semiconductor employees or workers in the country, second only to California and Texas. But and we have over 200 companies in the semiconductor ecosystem here in the state. So it's a tremendous asset. You have a all the pieces in place for workforce development with several community colleges that have fantastic programs, and then Oregon State and University of Oregon and Portland State and Oregon Institute of Technology, all having these programs that are producing graduates for these companies. Um, but we do need to keep in mind that other parts of the country are also building up their semiconductor programs. So the way I think that Oregon is going to come out ahead is being really meaningfully involved in these types of consortia, including what Oregon Business Council is doing with their semiconductor talent development program. And it takes a lot of effort uh, to volunteer time for these things, but it's really important that we keep emphasizing working together as a community and creating these opportunities for Oregonians to work in these really exciting and high-paying industry.
Well said. Exciting times. Well, thank you again for joining us. It was a pleasure to be able to speak with you.
Yeah, thank you, Skip. I really enjoyed it.